Hey everyone, picking up from where we left off in our last video. So, right at the very end, I kind of dropped on everyone that when you do LDR like this and you're loading equals loop, that what you're doing is you're loading the memory address of a code label using our LDR pseudo instruction. Now, remember how that all translates into what we call a program counter relative load, which is that funky LDR register and program counter syntax. So that's all good, we know about that. But what are we actually loading though, when we load a code label? Here's one I prepared earlier. So let's get our registers up over here and have a look. I'll do my LDR instruction here. So we remember that this translates into one of these program counter relative loads. So we'll do it. And what do we get in R0? Okay, we get this. Now, if you've looked in memory viewer enough, you can probably realize this is a memory address somewhere in our program memory space on the board. If you look in our disassembly view, you'll notice it's actually the address of our LDR instruction. And of course, we can find where it's been loaded from at our memory address over here in the memory viewer. And that's just after our program, as usual. So what actually is a code label then? A code label is simply the memory address of the first instruction after that code label. So main is the memory address of this instruction, as is loop. The code labels themselves aren't an instruction, so main is not the address of, well, main is the address of loop, and loop's address is this, so I guess they are the same. But yeah, so if you're ever thinking, what's the address of a label? Start at the label, look for the first thing that isn't a label, and that's what it is. So we've loaded equals loop into R0, and that is the address of the first instruction after equals loop, which is this LDR up here. Okay, so you might be wondering why you'd ever want to know about this. Well, let's find out. If we flick through our lecture slides here. Okay. Cool. We'll get to this slide now. I'm going to do some lazy copy paste coding, and we'll get back to what .data is in a moment. Okay, so we'll close all our windows and punch this in. Oh geez, I got a lot of extra stuff. On a quick aside here, your .size main line will always need to be before any .data lines. This is a fairly common problem in Lab 4 or Lab 5. So yeah, just make sure when you put .data, you put it after your .size main. Okay, reload my window. I'm reloading my window because Visual Studio Code's a little bit broken on my computer at home. Start our debug. Okay, get to our main file. Coolio, let's open up all our views, get our disassembly, and we'll get our memory viewer. Cool. Okay, put this over here, memory down here. It's very useful being able to drag these windows around to set up your little workspace here so you can really know what you're doing. Alright, so what are we doing? We're loading the memory address of the stuff label. Now, what's that going to be? Well, we'll go to our stuff label here. We'll find the first thing after it that isn't a label, and that's this, .word, 0x dead beef. So stuff is going to be the memory address of this word in memory, dead beef. We'll look up here. In our disassembly view, we're doing our program counter relative load to get that memory address into register 0. And sorry, let's bring up the register. Oh, now this is a different number than usual. We'll get to Y in a minute. And then we'll load from register 0 with no offset, so just register 0, and we'll load the contents into R1. we have dead beef. Now, you'll notice that this is a very different memory address to what you might have been expecting. We haven't just put our word here in memory after our program, because if we look in our program ends at 1cc, which is 1cc, that's here, is it? Yeah, so this is where our program ends, and we've got our memory address here, and then we've just got a whole bunch of random garbage. Our dead beef word actually isn't in here. So let's open up our memory viewer at 0x2, 1, 2, 3, 4, 5, 6, 7. Well, let's just call this 0x2 million or whatever. And there we go. But our dead beef is in here. 0x2, 0, 0, 0, 0, 0, 0, 0. So I guess we've answered the question of what this .data thing does. As the comment says, everything after .data goes in the data section. But what actually is the data section? Let's go back to our lecture slides, and hopefully they're going to be helpful. Mid-semester exam, in case you missed it. That's the deets. So what did we just do with our .data? Well, it turns out that .data puts the values in our random access memory, which is at a different memory address to our program. Our program is stored in our flash storage memory, which is, you can kind of think like just like the storage space of our microcontroller. But our RAM has a different memory address, and it starts at this one here, 0x2, 0, 0, 0, 0, 0, 0, 0. Does this have the very handy chart? No, it doesn't. Okay, let's go back. So what's actually happening? Well, I sort of lied a little bit earlier. This word is going into program memory somewhere, just not here. On the slide it suggests at some point that we try running our program without this loop copy data init function. And if we're wondering where that is, let's close some more windows here. Okay, so loop copy data init here. So what's happening is in our startup file, before we branch to our main function here, we've actually added a whole bunch of random stuff that you might not have seen before. So what loop copy data init is doing, so anything we put in a .data section is actually getting put in program memory somewhere else. And then our loop copy data init is dumping it all into into RAM. So if we run the program with this commented out, what's going to happen? So we'll hit play, and we're here. Now obviously this is not going to get copied into RAM. So when we do our load, what are we going to get? Here's our memory address. Now you might remember from, I think, lab 2, we had you load from this memory address. And what are we going to get? A whole bunch of random gibberish. So as it turns out, memory and registers in general tend to contain a whole bunch of random garbage if we haven't actually initialized them by writing to them ourselves. So that's what happens when we disable the loop copy data init. Because we haven't written anything to that memory, it's going to contain whatever random garbage was left in there by the startup script. I think that's all I need to cover on this. Okay, cool. So just to summarize, when we do load equals a label, we're loading into the register the memory address of the first thing after the label. And then when we do this load, of course, it will get it'll load what's at that memory address. So equal stuff is the memory address of the first thing after stuff, which is this word. And then we're loading what's at that memory address, which will be the word dead beef, into the register. And our .data means that whatever we put here will end up in our memory section instead of our program flash storage. Okay, I hope this video has been helpful for you. The next one will be on conditional execution. There we go, conditionals.